this lesson is going to be on cumulative frequency plots or cumulative relative frequency plots. Let's revisit the frequency table for test 1. So from here, it was pretty easy to determine the proportion of students who scored within certain classes, right? However, we often need to know the proportion of observations that fall below a certain value. For instance, we could ask what proportion of students fell below 70%, corresponds to an F or D in this particular class. One way to do this is to add up all of these values here. This particular sum is called a cumulative relative frequency. Now, it's often useful to create a cumulative frequency table that I'll demonstrate now. So we begin with another column. I'm just going to call this cumulative frequency. So the first one's going to be just a 1. Now we're going to add up the 1 and the 1 to get 2. And now we add up the 1 and the 2 and the other 2 to get 4. And so on. Now create another column called cumulative relative frequency. So the first one's 0.038. The next one, I'm just going to add 0.038 to 0.038 to get 0.077. Now I'm going to take 0.038 and 0.038 plus 0.077 to get 0.154. Similar on 0.231 and the rest until I get to 1. These should total to 1 or very close to it, like 0.999. Occasionally you'll be off a little bit due to rounding errors. So this is the lesson on visual displays. So let's graph this cumulative relative frequency. This is going to be called a cumulative frequency plot or cumulative relative frequency plot. Let me just look at the cumulative relative frequencies here so we don't have to get the other values in our way. And let's go and look at a table. So we begin typically with the 0 starting point. And we'll start the 0 with the lowest bound here on the first class. So we're going from 20 to 30, so we're going to start there at 0 because nothing's below 20. Now look at the first value of the cumulative relative frequency, which is 0.038. So we're going to use the value of 30, the smallest value of the next class up, and put a point at a height of about 0.038, in fact, exactly 0.038. And we're just going to sort of estimate that on the graph. So we'll continue with the next set of points. So we're going to put a value of 0.077 at the value of 40, value 0.154 at the value of 50, and 0.231 at the value of 60, and so on. And we'll often connect these graphs with a straight line, and sometimes this will even be smoothed out. So it's much more likely that you're going to be using computer software to create this and not do these by hand. It's even more likely that on the AP exam, you'll actually be asked to make some sort of interpretation when given the cumulative frequency plot or cumulative relative frequency plot. So let me give you a couple examples here. So let's use our plot to determine the percent of students who scored below 80 on the test. So we locate the dot where we're at 80% on the test, and we look over and we see that's at about 0.538. Now we could have looked at the table for this, but often we use the graph, the display, to approximate what this is. So I would say this would be approximately about between 0.5 and 0.55 or something like that. We can also go the other way, right? We can say, well, find the approximate grade that separates the lowest 20% from the highest 80%. So we go over here to the 0.2 on the cumulative relative frequency, which is 20%. And that looks like it's about 55, right? So about a grade of 55, people scored below 55 is the bottom 20% of the class. This is something that's harder to do from a table. So one last thing. So let's notice how the original distributions are actually related to the cumulative relative frequency plots. Let's compare 3 different types of distributions that we've seen so far. Left skewed, right skewed, and bell-shaped. Notice that with the left skewed distribution, most of the data comes at the far right. So its cumulative frequency plot will rise slowly at first and then get steeper. Similar reasoning will hold for the right skewed data. It will start off steep and then rise just slowly. You can see that the bell-shaped curve is relatively symmetric with regard to steepness on both ends. And so this is the bell-shaped curve here in the middle. So this is just another way, another visual display we can use to help us analyze the data. This is often used when looking at measures of position, which we'll see in a later lesson.